This is the lecture video for section 6.1. So this is the first video, and then we're going to first reviewing function. So we're talking about function, we're using the symbol f, and normally says what is the variable are we talking about, or what is the independent variable are we talking about. So when we're talking about function, is you can thinking about is a machine taking the input, which is the domain, and transport it to become an output, which is the range. And not everything can be a function. In order to be a function, we do need to make sure that for every element in the domain, it will corresponding to only one element in the range. Graphically speaking, if I have any shape of graph, okay, so for example, looks like this. It's really hard to check every single point or every single x value in the domain have only one corresponding y range. So we're normally using something called the vertical line test. So we draw bench vertical lines, and then we need to make sure every single vertical lines and the graph only intercept at most one point. It can be like there's no intersection, but when they do intercept, they only intercept at most one. Okay, so that's the function. Now when we're talking about inverse function, what we're thinking about is the return trip from the original range back to the original domain. For the return function, the inverse function, the return trip, the inverse function, the original range is domain, which is the input. The original domain, which is the input, becomes the range, which is the output. And we're normally using the symbol f to the -1, but that means inverse. Okay, so the inverse function is also a function, so it's also going to satisfy the same definition that for every element in the domain corresponding to only one element in the range. By combining both original function f and the inverse function f of inverse, that require the function f to have an inverse function we do need to make sure that every element in the domain of f corresponds to one and only one element in the range. Okay, so this is really important. We do need to make sure f is a one-to-one function. So what does that mean to be a one-to-one function? That means if I have a x in the domain and taking the f and transport it to some value f of x in the range, if I have a different x, so x1 and x2, it will transport it to a different location in the range. Graphically speaking, that for any function or for any graph of the function, it's not only need to pass the vertical line test for it to be a function, it also need to pass the horizontal line test in order for it to be a one-to-one function. Okay. So once we're talking about function and inverse function, we're just going to do one example. How, if I know a function can have its inverse function, how can I find it? How can I find this inverse function? So for example, I have a graph. The graph is the graph have the following, or made with the following point. Okay, so I have those 4 points on the graph. Then, as I mentioned before, the original function, the domain is our starting point, the range is our endpoint. But the inverse function, the range become to the domain, and then the domain become to the range, which means now y become to the x, and then the x become to the y. So what I try to say is to find the graph of inverse function, we simply just switching the x and the y coordinate. So that means the 2 and 4 becomes to the point 4, 2. 0 and 1 become to the point 1, 0. Negative 2, 0 become the point 0, negative 2. And then negative 3, negative 2 become the point negative 2, negative 3. So the corresponding inverse function graph looks like 4, 2, 1, 0, 0, negative 2. I'm not really graph it really nice. Negative 2, negative 3. Okay, by connecting them, and that's the graph. Okay. If you do want to, I'm probably just going to redraw it using more nicer, like more accurate graphings. Okay, so I have the point, I have starting point 2, 4, oops, 2, 4, 2, 4, 0, 1, negative 2, 0, and negative 3, negative 2. And then my new point by switching them is 4, 2, 1 0 0 -2, and then -2 -3. Okay, so by me drawing it really nicely, hopefully, what we see is the two function, they actually symmetric respect to the line x equals to y. So that means when we try to find the inverse function, we're simply switching the original point, the x and y, interchanging them. Okay. Then if I have a function, actual, like not graph, but I actually have algebra function, f of x equals to 2 over x plus 4, and I want to find its inverse, f inverse of x. Then to find it, I'm following the same ideas, the same process. Is first, I'm going to changing the f of x to a y, because f of x equal to y. F of x is just a fancy way to call y. Second, as I mentioned on the graph here, I'm interchanging my x and y. So I'm interchanging my x and y, so y become to x become to y. And pretty much here I already have my co-1 co-inverse function. But the look of the function is not very similar to what we traditionally have, which is y on one side, x as part of the equation. So now we're just going to simplify it to have y equal to something. So to simplify it, I'm just going to multiply the denominator and then distribute it. Keep the y part, so x, y will be on the left side, but minus the 4x, and then divide it by x. So the official inverse function will be 2 minus 4x over 2. So pretty much if I want to summarize it, your step 1 is replace f of x with y. Now your second step is interchange x and y. Now the following few steps is I'm going to solve for y. I want y equal something something x. And then the last step is replace, since I replace f of x with y, so I'm going to replace f of inverse x, or replace y with f of inverse x.